Hi, I'm Karen Lopez, and welcome to Introducing Data Modeling. We're going to get started with the first module, which is Introducing Data Models. And as we go through this, the modules that we're going to cover are an introduction to data modeling, a segment on normalizing data, designing logical data models, and designing physical models. And then we're going to wrap it all up with how to use these models, these processes, and all the information we've learned to leverage data model in Agile and DevOps projects. So let's get started. One of the reasons why you want to learn about data modeling, even if you're not going to be a data modeler, is you're going to be working with data modelers on all the projects that you work on, whether they're official data modelers, accidental data modelers, or part-time data modelers. You might even be asked to work with or review a data model or prepare one yourself. And your work will always be affected by the data models. Now, having said that, one of the interesting parts about data modeling is there's always a data model, whether it's written down or not. And that means that every single person on your project, including end users, are doing data modeling in their heads. They have an expectation of how the data interrelates to each other and what its properties are. The other thing is we're going to be working with entities and tables, attributes and columns. We're going to learn about relationships, whether relationships are optional or mandatory, and these eventually become constraints on the data. We'll work with primary keys and foreign keys, and we'll learn about the types of data models, conceptual, logical, and physical. We'll talk a lot about the process of data modeling, and we'll also talk about working with data modelers themselves. Now, a little caveat here is that this course focuses on transactional data modeling. That means not data warehouse data models, not dimensional models, but that's only because a lot of the concepts we're going to talk about still apply to dimensional models, and they even apply to NoSQL databases and data modeling as well. So, what is a data model? Well, one of the things you'll find is that a lot of people on your team have various definitions of what it is, or they think that there's only one kind. So the number one that comes to mind is a database design. So people think of reverse engineering a database and creating an entity relationship diagram or a view of their database. But other people think of data models as a business user requirements model, just a plain old diagram of a database, the dreaded word documentation, an active model, meaning one that's being used for model-driven development, and even defined state models for defined state configurations. All of these things are in conflict with each other, which is what we're going to talk about. So here's an example of one type of data model that represents the highly graphical portion of a data model, even though data models are more than that. And this has the various facts that we'd want to know about employees and candidates and departments. And even if we look in a bit closer, we can see that, there's the typical information about an employee. There's some information about maybe some of the data formats and whether the data is required or not. There's also some information about stewardship of the data and security and privacy. And then we have relationships. We're going to talk about these in a few minutes, and some other entities that we would want to work with their facts and their metadata properties. And one of the reasons why I point out those is that people think of the data model just as the diagram. But the real richness of a data model is all the underlying metadata, the definitions of the things, what we mean by them, what the expected formats are they required, and then all these extended things that we need to discuss with end users, we discuss with security teams and all the members on our teams to write down and get all in one model how we're going to deal with all of these things, but at a logical level. So in a logical data model, which this is an example of, these are things that we get answers to and put in the model so that we have them in one place. Now, one of the other great features of a data model is they get really big. So the models we'll work with will be fairly simple because we're working in labs. But in the real world, it would not be rare to see a data model like this one that has about 800 entities and thousands of relationships and tens of thousands of attributes and other features in it. And that's why data modeling is more than just diagramming a database. So another trait of a data model is they can have different display levels or different detail levels. So in this case, we have the same concepts. We just have the names of the concepts, the relationships between them, and maybe the definitions of them. And these types of models are perfectly valid and are often used to talk with higher level of business people or to document business processes and value streams, but without getting into the nitty-gritty details of what the format of the data is. So the three major types of data models are, we'll start with the conceptual model. And sometimes this is called the conceptual data model, but the trend now is to call them conceptual models because they don't have a lot of facts in them. They're those high-level, entity-only, relationship-only, typically used on strategic projects to do strategic planning or to help scope out work further on that will be used to develop the next model, the logical data model. The logical data model is all the detailed facts of what we need to know about the business, the processes, and what applications are going to need to do or what integrations need to happen, and a lot of details about those facts, but not to the point where it specifies how they're actually going to get built, because that comes next in the physical model, which is where we're doing actual physical design at the database level, choosing DBMS-specific properties, even to a specific version of that DBMS. And we're taking into account things like performance and backup and all the system admin things that need to happen in a physical model. So if we look back again at a conceptual data model where we just have employees and departments and job candidates and shifts. And if you remember from a previous view of a model, we had some other entities in here, but they've been left out of this one because they're too much of a detail. So in a conceptual model, you're really talking about the core concepts of a company and not so much the details that are operational or things that are used to get around some restrictions of relational systems. So this is your example. In the logical data model that we looked at before, of course, there are more facts and there's more metadata and there'll be a lot more entities that we'll see in those things. Literally, in a real-world data model, hundreds of entities and hundreds or thousands of relationships all going through there. And we'll get into more details that in the logical data modeling module. And then in the physical example, not only do we have a similar set of entities, but we might also have additional information, such as in this case, we have the owner of the table, we have very specific data types, we have indicators of what constraints are going to be used. We might have some more information about procedures or other things that are database features and some other specifications. And in that module, we'll talk about how to apply those.